Today, we are going to pull back the curtain on the secret numbers that control your Wi-Fi speed. They're called the MCS rates.
You know the feeling, right? You're streaming something perfectly, you walk a few feet into another room, and boom, buffering. What is actually happening in that short distance to just tank your signal?
Well, it's not some gremlin messing with your network. It's a system called the Modulation and Coding Scheme, or just MCS for short. Basically, your phone and your router are constantly talking to each other, negotiating for the fastest but also the most stable connection they can possibly get. And that negotiation is what sets your speed.
To really get how this negotiation works, just think of your Wi-Fi speed like a recipe. The final speed you get comes down to 4 key ingredients.
Okay, so these are the 4 big ones in our Wi-Fi recipe: modulation, spatial streams, coding rate, and the guard interval. The exact mix of these 4 is what gives you your final speed. So let's break down what each one actually does.
All right, first up is modulation. This one is all about efficiency. You know, how much data can you possibly cram into a single radio signal?
Think of modulation as the language your devices use to pack digital data, all those ones and zeros, onto a radio wave. A simple language is, well, simple to understand, but it's slow. A more complex, advanced language lets you send way more information in the exact same amount of time.
And this explains the trade-off perfectly. On one side, you've got simple modulation like BPSK. That's our bicycle courier. Slow, maybe, but super tough and can get through almost any interference. Then, on the other end, you've got advanced stuff like 4096 QAM, our cargo plane. It's incredibly fast, but it needs a perfect, crystal-clear signal to operate.
And you can see right here how each new Wi-Fi standard brought a more advanced, a denser language. With Wi-Fi 4, we could pack 6 bits of data into a signal. Fast forward to Wi-Fi 7, and we can now pack 12 bits into that same space. That's literally double the data, a huge leap in how efficient we can be.
Okay, let's move on to ingredient number 2, spatial streams. If modulation is about how much data we can pack into a single car, spatial streams decide how many lanes we have on our highway. This is the magic of something called MIMO, which stands for multiple input, multiple output. All it really means is using multiple antennas to create multiple lanes for data. So if your router and your laptop both have 2 antennas, they can send and receive 2 separate streams of data at the exact same time. More antennas, more streams, and yep, more speed. And here's that highway analogy in action. A single spatial stream is like a quiet, 1-lane country road. But modern routers, they can support 8 or even 16 streams, creating this massive data superhighway that can handle a ton of traffic all at once. Next up, we have the unsung hero of reliability, the coding rate. Just think of this as the built-in proofreader for all the data being sent. So because Wi-Fi signals aren't perfect, errors happen. The coding rate basically slips a little bit of error correction data into the stream. This lets the device on the other end fix small mistakes without having to ask for the data all over again. It's a classic trade-off. More error correction means a more reliable signal, but less room for your actual data. So a 1/2 rate is kind of like sending every word twice, just to be absolutely sure it's heard right. Super slow, but very, very reliable. A 5/6 rate is more like speaking quickly and just assuming the other person is smart enough to figure out any words they missed. It's much faster, but you need a really good connection for it to work.
And now, for our final ingredient, we have the guard interval. This is all about timing and preventing what are basically digital traffic jams.
You see, your Wi-Fi signals don't just go in a straight line. They bounce off everything. Walls, furniture, you name it. This creates echoes that can arrive just a split second late and mess up the next piece of data. The guard interval is just a tiny programmed pause that gives those echoes a chance to fade away before the next bit of data is sent. A shorter pause, and we're talking nanoseconds here, means you can send data faster, but it's a bit risky in rooms with a lot of echo. A longer pause slows things down just a tiny bit, but makes the connection much more solid. Modern Wi-Fi can even use extra long pauses for really tough outdoor situations. So we've got our 4 ingredients: modulation, spatial streams, coding rate, and guard interval. So how do they all come together? Well, they're combined into these preset recipes that are listed in an official menu called the MCS index table.
Okay, take a look at this simplified table. On the far left, you see the MCS index number. That's the recipe number. If your device picks index 0, it's using the slowest, most reliable combo, basic BPSK modulation and a 1/2 coding rate for maximum error checking. But if the connection is perfect, it might jump all the way up to index 11 using super fast 1024 QAM with a leaner 5.6 coding rate to get every last drop of speed.
And the full table is absolutely massive. It has to factor in every possible channel width and number of spatial streams. If you're curious and want to go down the rabbit hole, the absolute best resource is mcsindex.net. Seriously, it's a fantastic site.
So this brings us to the biggest question of all. How in the world does your phone or your laptop know which recipe to pick from this giant menu at any given second? Well, the decision all comes down to one key measurement, signal-to-noise ratio, or SNR. Think of it as just a measure of signal quality. A high SNR is like being in a quiet library, where you can hear a whisper perfectly. A low SNR is like trying to have a conversation right next to the stage at a loud rock concert.
And this brings us right back to that question from the beginning. When you're standing right next to the router, the signal is crystal clear. That's a high SNR. So your device confidently picks a high MCS rate for maximum speed. But as you walk into the bedroom, the signal gets weaker, the noise gets relatively louder. That's a low SNR. Your device senses this and automatically, intelligently, switches to a lower, slower, but much more reliable MCS rate to keep your connection from dropping.
And this is happening all the time, dozens of times a second, without you ever even knowing it. The goal is never just the fastest possible speed, it's the highest reliable speed for the conditions you're in right now. And that constant dynamic adjustment is the secret to why your Wi-Fi speed changes from room to room. If you enjoyed geeking out on this stuff, be sure to subscribe for more explainers just like this. Thanks for watching.